Are static cloud scans still enough to keep your environment safe? In this review of Upwind, a runtime-first CNAPP app, we will explain how a shift from periodic snapshots to continuous execution context can dramatically improve the signal-to-noise ratio of your cloud security program. We will cover how it works, what makes it different, where it fits against competitors, and what to evaluate in a proof of concept. Let's start with the problem. Modern cloud environments are dynamic. Containers scale up and down in seconds. New microservices appear behind internal APIs. Ephemeral nodes and serverless functions come and go with each deployment. AI workloads may pull in large datasets, introduce GPU-accelerated compute nodes, and create new east-west traffic patterns. Traditional tools that rely on static configuration checks detect what could be risky in theory, but they lack the runtime context to determine what is truly exploitable in practice. That gap leads to alert overload and slow remediation. Upwind addresses this gap by making runtime the primary source of truth. Instead of only listing misconfigurations or vulnerabilities, it correlates them with what is actually running, how services are reachable, which identities can access them, and what data paths exist between the internet and critical workloads. This helps teams focus on a short list of issues that matter now, rather than thousands of theoretical findings. How does this approach work? At a high level, a CNAPP like Upwind connects to your cloud accounts in AWS, Microsoft Azure, and Google Cloud Platform to ingest configuration metadata. It discovers assets such as VPCs and VNets, subnets, load balancers, security groups, firewall rules, storage buckets, container registries, Kubernetes clusters like EKS, AKS, and GKE, and serverless services. It also observes workload state and relationships, which pods, services, and deployments are live, which images they run, how they communicate, and whether they are internet exposed or internal only. The runtime-first component is crucial. When a vulnerability is found in an image, Upwind checks whether that image is actually running, whether the specific container is reachable from the internet or from other sensitive tiers, whether network policies allow ingress, what identity permissions are attached, and whether secrets are present in environment variables or mounted volumes. Only if a path exists from a threat source to a vulnerable asset is the issue prioritized to the top of the queue. Otherwise, it is documented but deprioritized. This prioritization improves engineer focus, accelerates mean time to remediation, and reduces fatigue. What about AI? The core value here is not a chatbot layer. Upwind emphasizes explainable correlation based on runtime telemetry, attack path calculation, and identity context. If machine learning is used, it supports pattern detection and anomaly scoring, but the outcomes remain transparent. You can see the path from an external entry point through a load balancer or API gateway into a namespace down to a pod with a critical CVE. That clarity enables faster decisions and easier cross-team collaboration between security, platform engineering, and application owners. Key capabilities to look for when you evaluate Upwind include the following. First, runtime exposure analysis that merges CSPM, vulnerability data, and live network reachability. Second, attack path mapping that visualizes how an external or internal threat could move through your environment. Third, Kubernetes native context, including namespaces, network policies, and service-to-service communication, so you can contain blast radius. Fourth, identity and access risk analysis to understand which roles and service accounts can reach sensitive resources. Fifth, drift detection between the image in your registry and the container in production to catch changes or injected binaries that scanning missed. Sixth, integration with CI pipelines, registries, and ticketing tools to push prioritized fixes to the right owners. Let us compare this with leading alternatives. Wiz and Orca Security popularized agentless posture scanning and graph correlation across clouds. Prisma Cloud offers a wide integrated feature set across CNAPP categories. Lacework brought strong behavioral analytics. Many suites grew through acquisitions that introduced multiple consoles or data models. Upwind differentiates by making live execution states central rather than a supplementary signal, which tends to reduce duplicate and non-actionable alerts. The trade-off is that you must plan for the runtime data collection you need and confirm coverage for each cloud service and Kubernetes distribution you run. Who benefits most from Upwind's model? Teams running Kubernetes at scale and microservices with frequent releases, organizations exposing APIs to the internet, and enterprises introducing AI pipelines that move sensitive data among storage, compute, and model endpoints. Platform and SRE teams get a clear picture of blast radius. Security engineers receive fewer, better prioritized tickets. Leadership sees measurable risk reduction because the findings are tied to reachability and real execution. What are the limitations and considerations? Any CNAPP requires read permissions to cloud accounts and often optional, lightweight sensors for richer runtime context. You should validate data egress policies, privacy controls, and regional data residency. Coverage depth can vary. For example, managed databases, message queues, and serverless services differ by cloud and may have different levels of runtime visibility. Costs generally correlate with the number of cloud accounts, clusters, and ingested signals. Ensure you scope a proof of concept that mirrors production scale. Finally, the value of prioritization depends on breadth of onboarding. The more accounts, clusters, and registries you connect, the more accurate the attack path analysis becomes. How do you evaluate Upwind effectively? Start by defining clear success criteria. Reduce alert volume by a target percentage, shorten mean time to remediation for your top 5 risky services, and demonstrate at least 3 attack paths that translate into concrete fixes. Connect representative AWS, Azure, and GCP accounts, include at least one production-like Kubernetes cluster, integrate your container registry, and import ticketing systems such as Jira or ServiceNow. Measure how quickly owners receive actionable tickets with precise remediation steps and how often those tickets close without back-and-forth clarification. What outcomes should you expect if the fit is right? A shorter list of prioritized risks grounded in runtime context, faster remediation because ownership is clear, better audit posture with evidence that you address reachable, exploitable issues first, and improved collaboration between security and engineering through shared, explainable graphs of exposure and identity paths. In summary, Upwind CNAPP is designed for the reality of modern cloud, fleets of short-lived workloads, complex identity relationships, and constant change. By building around runtime insights rather than periodic snapshots, it helps organizations focus on the exposures that matter most. If your teams are drowning in alerts from traditional scanners and struggling to determine what is actually at risk, a runtime-first evaluation of Upwind is worth your time. Validate coverage for your specific cloud services and Kubernetes distributions, confirm deployment and data handling approaches, and measure results against clear, business-aligned success criteria. If those boxes check out, you will likely see fewer alerts, faster fixes, and a stronger security posture aligned to how your cloud truly runs today.